Today we're going to look at factoring quadratics when a is not 1. What that means is if you had standard form, ax squared, bx, and c, quadratic, something with an exponent of 2, and when the number in front of that is, in front of the x squared is not 1, that's what we're going to be dealing with here today. So 4, 10, 5, all that kind of raises a little problem. Okay, so factoring, we need to figure out two groups of numbers, two parentheses multiplied together to give us these answers. So we start, when you've got a number that's not 1, we're going to start by multiplying. Let's multiply the beginning and the end together, and you get 30. So what we're about to do is we're going to kind of we're going to turn these questions or these problems into a grouping, factor by grouping, to make it a little easier. So we start by multiplying, and then find your factors of 30. What two numbers multiplied together give me 30? Of those, I need to figure out which pair can give us a 13 by adding or subtracting. So in this case, we end up with two examples, 3 and 10 and 2 and 15. So because there's a plus and a plus here, we're going to have to add those two numbers together. So that's why I'm leaning on this plus 3 plus 10. If I deal with the 2 and the 15, there's going to have to be a subtraction problem. That would mess up one of these signs. So let's stay away from that. So let's create a new problem now. 5x squared plus 3x plus 10x plus 6. Now again, this 13x turned into 3x and 10x. Why? Because my factor of 30 that I got from here, I can break it up into 3 and 10. Those two numbers added together give me this. So let's group. First group, what do they share? In this case, x. And then let's distribute back in to see if we can come up with what multiplies together to give me this. So x times what gives me 5x squared? 5x. X times what gives me 3x? Just 3. On the other side, 10x and 6, what's a number that they both share? Well, they're both even numbers, so they both share 2. 2 times what gives me 10x? 2 times 5x. 2 times what gives me 6? 3. Now, both parentheses are the same. That's good. Keep one. And then the other parenthesis we're going to create with the numbers that we factored out. So x plus 2. And you're factored. Let's do it again. 10x squared minus 35x and 30. So we got some big numbers. Now, if we start this whole problem off by multiplying your first and your last, I'm going to end up with 300. I then have to find all my factors of 300. It's got to be an easier way. There is. Do all three terms share a number? They do. The number 5 goes into each one of those. So before we do anything, let's factor out a 5. 5 times what gives me 10x squared? 2x squared. 5 times what gives me negative 35x? I'm going to say negative 7x. 5 times what gives us 36? Now, I'm dealing with smaller numbers. I can then multiply those two things together. And now we can continue on with the process that we did over here. So 2 and 6 gives us 12. What two numbers multiplied together give us 12? 1, 12, 2, 6, 3, and 4. Of all of those pairs, what adds or subtracts to give us a 7? 3 and 4, but I need a negative 7. So I could just say negative 3, negative 4. Now I want to rewrite this trinomial on the inside as a grouping problem, as 4 terms. So I'm going to bring down that 5 again. 2x squared minus 3x minus 4x plus 6. So again, this 7 turned into this 3 and 4. Why? Because we took these Found the factors and what gives us 12, or what multiplies together gives us 12, but adds or subtracts to give us 7, 3, and 4. Now, let me change these parentheses to brackets, see if this helps. Because I want to group. And I want to group, put a little placeholder in there. So now, first set, what do we share? We share an x. X times what? X times what gives us 2x squared? Just 2x. X times what gives us negative 3x minus 3. 4 and 6, what do we share? We share 2, but because there's a negative there, let's pull a negative out as well. Negative 2 times what gives us negative 4x? We're going to say 2x. Negative 2 times what gives us 6? Negative 3, because we have a negative and a negative gives us positive. Now, all of this is everything that we have in brackets. I know this is looking sloppy. But when we factored by grouping, that's the same as that. So let's keep 1, 2x minus 3, and then create the second one with what we already took out, x minus 2. And the only other thing that we have here is a 5. You don't need these brackets anymore because it just says multiplication. Let's just continue multiplying it down. Bring that 5 in to the group. All right, and one more. So we could take something out here. Let's see if we could take anything out here. 4, 3, 5. We don't share anything. There's nothing we could factor out. So next step. Let's multiply these together. 4 and 5 gives us 20. What are two numbers multiplied together to give us 20? Come up with a list. 120, 210, 3 no, 4 and 5, and then that's it. Of all of these pairs, will any of them add or subtract to give us a 3? Nope, nope, nope. Because there's nothing that will multiply together to give us this 3, I cannot factor this trinomial. But I can't just leave it blank. Because I can't factor it, I still have to write something. I still got to show that I'm doing the work. I did the work here. It says I can't do it. The answer is not no solution. This time, the answer is prime. We're saying that the only factors of that trinomial, that polynomial, is 1 and itself. Because if you multiply by anything by 1, you still get the same thing. So prime. It's possible to not be able to factor. And that is factoring a quadratic when a is not equal to 1.